example of a falling object problem here. We've got a ball that's dropped from the top of a cliff. If the ball strikes the ground below 6.45 seconds later, how high is the cliff? So what we've got is we've got a cliff here and a ball that's being dropped, and 6.45 seconds later it lands. We want to know how tall the cliff is. Again, I've really stressed keeping organized. We're going to go ahead and put together a table here. We've got our 5 variables: change in position, velocity original, velocity final, time, and acceleration. We are only interested in the vertical direction here. There is no horizontal since it's dropped straight down. And what we want to do is we want to fill in what we know here. We know that we're looking for the change in position. We want to know how high the cliff is. V0, since we're dropping the ball, V0 would be 0. V final, we're not told and we're not asked about, so we'll just kind of skip over that. Time is equal to 6.45 seconds. And then acceleration, since it's a falling object, negative 9.8 meters per second squared. Probably a good place to start is with the equation for change in position, which is equal to V0t plus 1/2 AT squared. We don't know change in position. We're solving for that. We know V0. We know time. We know acceleration. We know time. We've got everything. We should be able to figure this out. So change in position is going to be equal to V0t, which is 0 times t plus 1/2 times negative 9.8 meters per second squared times 6.45 seconds squared. This I didn't put a number in because that's going to go away. 0 times anything is 0. So we get change in position is going to be equal to negative 4.9 times 6.45 squared, which is going to be equal to, there we go, negative 4.9 times 6.45 squared, and that's going to be equal to 203.9 meters. 203.9 meters, and that was negative. That is the change in position. Keep in mind this is 0. This is 203.9 meters up here. My change in position is going to be final minus initial. So this is my final position. This is my initial position. So change in position for something falling is going to wind up being like 0 minus 203.9, which is going to give me a negative. So my change in positions are going to be negative. But the question is, how high is the cliff? Really interested in the negative. We just want to know what this distance is. So the answer is 203.9 meters. A couple of key things to remember for a falling object when it's dropped. When it's dropped, V0 is 0. And again, acceleration for a falling object is always negative 9.8 meters per second squared.